Let us solve this problem today. The force shown in the graph below acts on a 1.2 kilogram object moving at 120 meter per second. The direction of the force is aligned with the velocity. What is the new velocity of the object? So here the graph shows ft curve. So force and time. So time on x-axis and force on y-axis. So the maximum force applied, and they are asking to find out the velocity at this point. So this is 0.4 seconds and this is 0.5 seconds. So the time duration is 0.5 minus 0.4, that is delta t equals to 0.5 minus 0.4, that is 0.1 seconds. 0.1 seconds. Now, what is the force applied here? So, since from the graph, this is 500, 1000, 1500, 2000 and 2500. So, maximum force applied is at this point, is equals to 2500 Newton. Okay, now let us find out the velocity. And the area under this curve in ft graph gives the change in momentum. So let us find out the change in momentum first. So change in momentum delta P is equals to area of the triangle. So this is equal to half times this delta T times F. So this we can calculate as half times 0.1, because delta T is 0.1 times 2500. Okay. So this we can calculate and we can write it as 1250 into 0.1, right? So 125. And this is momentum, so we can put the units as kilogram meter per second, right? So now to find out momentum, this is from graph. Okay, so to find out this change in momentum is equal to delta P is equals to, this is from the curve F times delta T, half of that F times delta T. But actually momentum is initial momentum, and with final momentum and initial momentum we can find out the change in momentum as mv final minus mv initial. That is, this is final momentum and initial momentum. So mass times Vf minus Vi. And this we have already calculated, that is 125. So we can write the equation first. Either you can calculate the value first and do the problem, or you can write it as momentum is equals to, that is 125 equals to m times Vf minus Vi, or Vf minus Vi equals to 125 over mass. So Vf, that is final velocity, equals to 125 over mass, then plus V initial. So let us substitute the values now. 125, and the mass is given as, see, it is given in the problem, 1.2 kilogram, and initial velocity is 120 meter per second. So this is 1.2 kilogram plus 120 meters. So now if you calculate 125 by 1.2, you will get 104.2 approximately, right, plus 120. So this is equals to 224.2. So since this is final velocity, we can write it as meter per second. So because this is velocity and the units are meter per second. So the area under the curve, we are taking it as half delta t times Vf, because this is triangular shape. Okay, and this is from the formula. So by equating these two, from graph calculated change in momentum from graph is 125 kilogram meter per second, and the same momentum change in momentum calculated with the formula initial momentum, final momentum. So the change in momentum is final momentum minus initial momentum. So by equating these two, we are finding final velocity, which is 224.2. This is the answer.